Good evening, sir. I'm Ng Chin Huan, and my group partner is Wan Muhammad Azlan. We are from Group 1. So first, I will explain about the task 2 because it is quite complicated. So first, the user will key in main memory size, for example, 4096, and page size, for example, 1024. Then the program will determine the number of page frame, which is E, by dividing the main memory size by the page size. For this example, we get 4. Now I will explain task 2 by using this diagram. Okay. So since E is equal to 4, our physical memory has been divided into 4 page frames. All pages consist of 1024 words. So the concept of this program is when the virtual memory address that we access haven't exist inside the physical memory, page 4 occur. The page will then brought into physical memory using LRU policy. If the page already exists, the program will show when the page have been mapped to. Okay, first we enter 6142. So the page fault occurs. So 6142, which is in VP5, will be mapped to PF0. So the page table will show VP5 to VP0. Second, we enter 2310. So the page fault is also occur. The 2310, which is in VP2, will be mapped to PF1. So for the page table, will show VP2 to PF1. So third, we enter 1000. Okay, so the page fault also occur. So 1000, which is in VP0, will be mapped to PF2. So the page table will show VP0 is mapped to PF2. So the fourth, we will enter 2049. Okay, so this time the program shows that the page already exists. So the page table will remain unchanged. Fifth, we will enter 999. So the program shows that the page already exists. So the page table will still remain unchanged. 6, we will enter 9000. Okay, this time page fault is occur because 9000, which is in VP8, will be mapped to PF3. So the page table will show VP8 to PF3. So this is the final output, which is VP5 to PF0, VP2 to PF1, VP0 to PF2, and VP8 to PF3. So this is the manually produced page table for the least recently used algorithm, which we learned from last semester. Okay. Now I will explain the coding. Firstly, we create a struct named node. VP represent virtual page and PF represent page frame. Lastly, we create a pointer PT of type struct node and initialize it to null. This is the set param functions, which require user to input the main memory size, the page size, and also select the replacement policy. The number of page frames will be stored inside the variable E. The dynamically allocated memory will be stored inside PT. So this for loop initialize each entry in the page table by setting the VP to -1. Okay. This one is the map function, which require user to input which virtual memory address that they want to access. So I will show how the program calculated VP and OO. Okay. VP is used to determine the location of the virtual memory address inside the inside the virtual memory. For this example, 6142, so we get 5.998, which means that it's located inside VP5. OO is used to calculate the offset within the page. For this example, we get 1022. Okay. So for this part, the program will determine either page fault occur or not. If occur, memory mapping will be performed by using policy that have been selected. So for print page function, is used to print the page table so that we can keep track the mapping between the virtual memory and the physical memory address. Lastly, the quick function is used to release the memory allocated for the page table. So now I will pass to my partner, Azlan.
I am Wanmam Azlan, and I'm gonna explain about the task 1 from the lab 2. From the coding, we use include std let.hash, which we use std library so that we can use the malloc function. For the next is we use void populate so that we can create a populate function that take. For str equal to char multiply malloc in bracket of size of character. We use this as to allocate memory dynamically. Also, the size specific in the head and the typecast to character. So for strcpy, in bracket of multiply str memory, that is the correct method to copy string memory to the pointer. So for str equal to memory, this is the wrong method because the string will overwrite the dynamically allocated memory and cause memory leak. For the inside the int main, we use char s. Inside the main function, we create a pointer s. For populate, we will call the populate function by sending the address of s. As the printf, we will print the string memory, and lastly, we will free the memory.
If we run the output with pointers str equal to memory, so
we
it will cause the undefined behavior. So if we eliminate this statement, so we can run the output without any error. So that is all from us. Thank you.
Thank you.